Welcome, and in this lesson, we're going to work on learning how to use the grep utility in order to search and analyze text. So the grep utility allows us to use patterns in order to search for specific results based off the pattern that we pass in. So first, I'm just going to do a VIM on a file named file. We're going to use this to basically create some generic information for us to manipulate using grep. So let's just fill this out. I'm going to fill out just a few lines of text here. I suggest that you would do the same. I'm going to do hello Linux Academy, 2 words. Linux Academy, hello world. Hello world Linux Academy. Linux Academy. Linux Academy. Linux Academy. Comment or hashtag Linux Academy. The comment symbol, hashtag Linux Academy. Let's throw in a couple lowercase letters and uppercase letters in here. Let's do a sequence of A's. Let's also do A bracket 1, close bracket, 1, 2, 3, 1, 2, 3. And then a LIONUX Academy. Wow, we got a lot of words in here. So what are we going to do? Well, what we're going to do is we're going to learn how to use grep to look for a specific pattern, a sequence of rows, and return that information to our standard output using grep. Now, this is important because we use grep in order to parse through log files, look for specific information inside of configuration files inside of our system. And so let's just first get started demonstrating some of this. So first, what I want to do is, let's say I want to pull all commented items from our SSH configuration file. I could very simply do a grep and then open quote, single quote, and I'm going to look for every line that starts with a hash because I know that is a comment inside of my SSH configuration file. And I'm going to search the file etc ssh sshd config. So what am I doing here? What is the syntax? We're using the grep utility. This is the pattern we're searching for, and this is the file that we are asking for it to pass. And so if I hit enter, you'll see everything in our standard output that's sent here starts with a hash, and it's actually in red because the grep program is returning that in red. That's what we searched for. So all of these fields are commented out inside of our SSH configuration file. I can look at the regular SSH configuration file and see those commented credentials. So if I weren't going to pass that, what would happen is, well, it would just not pass anything because we're not searching anything. Because what we're doing is we're manipulating the text on our screen to find information. So if I wanted to pull the RSA authentication variable, I could say grep. And I'm going to do -i. -i means case is not sensitive. Ignore case. And I'm looking for the RSA auth field inside of the etc ssh underscore config configuration file. Now, if you notice here, I just looked for RSA auth. It's going to return everything that matches that pattern from our SSH configuration file. So here I can very simply see, all right, well, our RSA authentication set to yes is commented out, so I know that this isn't set. So this is how I can parse through text using grep. It's a very useful tool for us. So a lot of times I might also go through a specific file. A lot of times I might want to look at values of a user in my system, or maybe I want to see if there's a user that's already been added to the system. Now, I know you can use the getInt command, but let's say you wanted to use grep to say grep etc the password d file, and let's say we're looking for the user. Well, okay, we know that here's the user patterns that are matched inside of my etc passwd file. And here's the user. If we were looking for the user Jeff, well, Jeff's not a user on my system, so nothing is going to be returned. Okay, so what are different ways we can use grep for manipulating text? Well, we created our file here with our different patterns. And what we're going to do is we're going to learn how to use regular expressions to, well, cause this to return specific results from the file. So for example, if I wanted to pull everything that was not a comment on the system, right, I could just do grep -v. -v means the inverse. Select lines of those that do not match our specified pattern. So I'm specifying I want it to start with the hash. Okay, well first let's look at this special character here. It's a caret. This caret means the line starts with this pattern. Well, since our Linux Academy line here starts with that pattern, which is just a one character hash, well, we're going to expect for, if we had the -v flag there, all of our lines to be returned except for our commented Linux Academy one. So if I parse that through, you'll notice that everything is returned except for our Linux Academy one. If I come back and I remove our inverse flag, our -v, you'll notice that it only returns the lines that start with Linux Academy. Now, I could change this as well and say, okay, I want to return all lines that start with hello. Well, there are 2 lines in my file that start with hello. And again, this could be important when we're working through our log files. If we're going through the kernel ring buffer, the dmessage command, and we want to return everything that has to do with memory, we could pipe dmessage over to the grep command and look for memory. And it's going to return everything associated with memory. Now notice what I did here. I actually chained my commands together. I did a dmessage, which created standard output. I then piped that standard output to my grep program, and I looked for the pattern that matched memory. So let's pull all lines that end with world. Well, how would we do that? I would do a grep, and then all lines that end with it. So world, and then $sign. A $sign means match the ending position of a string or the position just before a string ends a new line. So we have world $sign here and file. So what happens here is this says this is going to be the last string. The file is going to be the last string ending. So world is there, but technically I could probably say DMY. I could grep DMY and then our $sign, and then file. Now this should return everything that ends in DMY, even if it's part of another string, and it does. So how would I grep for all lines that just have the word Linux Academy on it? Well, grep-i, this way we can make sure we're not case sensitive, because grep is case sensitive. If I were to grep for Linux Academy inside of our file, you'll notice that because I have -i, well, all of them are being returned. If I remove my -i, it's only going to look for the exact pattern of lowercase Linux Academy. All right, so we have grep-i, and we have the Linux Academy here. So let's look for everything that starts with Linux Academy and ends with Linux Academy inside of our file. So we have 2 lines here that start and end with Linux Academy. So this means it only has the word Linux Academy. That's the only thing inside of that line, nothing else. So if we look at it, we have Linux Academy and Linux Academy. Because remember, we did the -i, so it is not case sensitive. So I can also specify something inside of brackets here. So if I said grep L or capital L, and then I spelled out Linux Academy, and then file, what this would say is, all right, if it starts with a capital L, and the rest of it is Linux Academy, or if it starts with a lowercase l and the rest of it matches this pattern, then return that. So you'll notice that we have all of our lowercases here. We don't have an uppercase L that matches the pattern. Now we do have one that starts with an uppercase L, but the uppercase A in here makes it not match this pattern, because these brackets say anything that matches the first digit here, either lowercase or uppercase, and the rest of the pattern. So it can either be a lowercase l or an uppercase L, and then Linux Academy in the pattern. And we can combine these together. We can say, all right, well, I want to make sure that it starts. I'm going to put the character on there, the character caret on there. And then it starts with it either a lowercase or uppercase, and then the Linux Academy pattern. We can also instruct it to return everything that does not match a digit. So if I open up a bracket, and then inside of the bracket, I do the character. What we're saying here is we're saying negate this. Do not match it. So if we say Linux, what we're saying is do not match the L character, do not match the I character, do not match the N character, or U character, or X character. So what grep will do is it will match any character that's not contained in our brackets. So if you look at what it returns in red here, this is showing what's being returned. Our characters that were being negated are not being matched. That's why they're not red. So it's returning everything that's not inside of this bracket. Now what I want to do is I want to introduce you to a few more characters, and then we'll go look through some log files. So this is all inside of your downloadable study guide on the linuxacademy.com Red Hat certification course. So what's going to happen is we've learned a few characters here. We learned the character. When given by itself, it's going to start the line with something. The line starts with this pattern that follows this. Then we have, if that character is inside a bracket, what it does is it negates the pattern inside of our brackets, or those specific characters inside of our brackets. So we've also learned the $, which matches the ending string of a specific line. So let's go ahead and get a little bit more complex. And we're going to learn about regular expressions and then extended regular expressions. But we're going to take this from a very simple overview so you understand what's happening. Now, inside of basic regular expressions, we have characters like the question mark, the plus sign, the bracket, the pipe, and our parentheses. These have special meanings, just like our $, or our caret. These have special meanings. In fact, we have a dot too. And we're going to talk about what these do. So first, let's take a look at the question mark. The question mark means the preceding item is optional and is matched at most one time. So we talked about basic regular expressions, and we had our question mark, our plus. I was just referring to those a second ago. Now, what happens is when we use those within grep, in order for them to work, we would have to parse them out, kind of like this. This is what gives them their special meaning. That's considered a basic regular expression. If I were to use extended regular expressions, I could just do the -e or the egrep command and then issue out what I was looking for. So for example, plus means the preceding item is matched one or more times. So if I'm looking for A, and then I pass a plus after it, and then my file, what's going to happen is it's going to say it's matching one or more times. So it's matched once. And here it is matched multiple times, or because we have more times. Now let's do a grep. And let's say I'm going to grep for everything that starts with an L and has 3 characters in the middle of it and then ends in X. So LINUX, and then file. So this dot means any single character, as long as it starts with an L, has 3 characters in the middle, and ends with an X. And so what happens is it's going to return everything that results Linux. There's a lot of regular expressions that we can do. In fact, it's a really complex subject that really could take a course in itself in order to go through all of our regular expressions. What I wanted to do is I wanted to introduce you to how to use those and really the basic regular expressions that might be common when we're working inside of a Linux environment. So for example, if we were to go and take a look at our etc password file, we know that over here, the last colon is our shell. So let's say we wanted to see which accounts did not have a shell associated with it. Well, that would mean that our file here would end in our colon. So we could do grep and then our colon $, which represents the end of the string or end of the line, and then our etc password file that we're parsing through. Now they all currently have one, but let's say, all right, well, we're looking for all of our no login. So I could just say, let's grep for no login, which users have no login on their shell. If we go into our var log directory and we take a look at our messages, or parsing through our messages, let's log in as the root user. And let's cat messages. Okay, well, there's a lot of information here that's just for messages, and we want to break this out a little bit. I want to pull all of just, I don't know, everything related to systemd. So I would do grep, we're looking for systemd, and then I'm going through my messages file. So what that did is that parsed everything through systemd. Now I want to pipe it out a little bit more, and I want to say, all right, well, I want to grep everything that represents a service or daemon being started. So I'm just going to go ahead and pipe it through grep again, and I'm going to match everything that starts with start. because it goes started or start or starting. So we'll pipe it through there and we'll look for everything that then matches start. So we're looking at all systemd, and then now we're matching everything that's starting with start. Okay, well, let's say I want to look for everything that's systemd for the desktop service. We'll now go through there, and now we see all of our messages that are related to our desktop service. And we can use our regular expressions to make it a little bit easier for us when we're parsing through files. If we're not quite sure what we're looking for, if we want to make sure that case isn't insensitive, we could do -I to make sure case is insensitive. And so that's how we use grep to parse through files and log files for information. Think of it like this. We're filtering out, looking for a pattern of information from a file, and we're usually doing that because grep can accept a file as a parameter on a file itself, or we could say cat, a file name, and then pass it to the grep program. And we can look for everything with the desktop message. So that concludes it for this lesson. Go ahead and complete this lesson and move on.